there are total 180 questions as per current exam content outline. So out of 180, maybe 2 to 6 questions, but it's again very rare calculation. So about 1 to 3% about math interpretation related questions. Okay. So PMP Math is more about understanding concepts, and it will make you think like a project manager, using numbers to make decisions, manage risk, and check project status. So by mastering this PMP Math, you are not just preparing for your exam, but you are strengthening your real world PM decision making skill. Okay, so this exam expects you to understand what the numbers mean, when to use which formula, how to interpret the result for decision making. Okay, and this exam tests your ability to apply formulas in context and not much memorization. Okay, and mostly it's very simple and not complex calculations involved. So at Exam Center, they do provide you calculator and paper and pen if you need to do some calculation. In my case, I was provided the digital calculator. It's on screen. Okay, so next slide. So math questions show up across multiple domains like schedule, cost, quality, risk, and so on. Okay, so many students, they get overwhelmed with these formulas, but mindset really matters here. Because it's not rocket science, it's more about structure. Okay, so every formula is tied to a real project management concept. So once you understand the concept, the math becomes very intuitive. So think of formula as tools in a toolbox, right? So you don't use all tools every day. But you need to know which one solves which problem. Okay, so which formula you need to use for given question. So we will break this PMP Math into a few clusters here, as you see on the screen. So communication management, you will need to know the communication channels, then cost management, risk management, schedule management, and so on. So let's start. And one more thing here. So avoid common pitfalls, mixing up similar terms. Like on the screen, you might be seeing one as EMV versus EVM, right? So EVM is earned value management, while EMV is expected monetary value. So yeah, during this session, you will clarify some of those terms, and we don't need to do much overthinking. PMP Math is really simple than it looks. Okay, so let's continue to the next slide.
Absolutely. I totally agree with Palak here. So PMP Maths is little simple as compared to what we actually think. So it's more of learning, it's more of understanding the basic and not, overthinking on this. So we'll start with the communication channels. The basic formula and the most simplest one here is channels is n minus 1 by 2, right? Where n is our number of stakeholder. In any project, communications we know is crucial for success. So as the number of stakeholder increases, the number of communication channels grows exponentially. That's how it works. So this formula n minus 1 by 2 calculates the total possible communication paths between the stakeholder. Understanding this helps the project manager anticipate communication challenges and design effective communication strategy as well. So no rocket science here, just a simple formula. Sometimes you get a very simple question, something like this as well. Moving on, the next slide here is where we talk about risk and probability. Now, few minutes back, Palak was talking about expected monetary value. That is EMV. What is this EMV? EMV is probability into impact. Now, expected monetary value, this is a quantitative risk analysis technique, which is used to evaluate the potential impact of the risk. It combines the probability of a risk of event which is occurring with the financial impact it can cause, right? So say, for example, if the risk has 30% chance. That's the probability. So 30% chance of occurring, and it cost around $100,000. So what would be the EMV? Yes, the EMV is 30K. So EMV helps prioritizing the risk by their potential cost to the project, guiding the decision making on risk responses and mitigating the strategies. So this approach supports the data driven risk management and better allocation of resources to address high impact risk.
Its most practical parts of schedule management as the math behind how we plan, sequence, or analyze project timelines, right? So these formulas aren't just for the exam, but how, as a real project manager, we understand float or critical path and schedule flexibility. So first here is critical path method. So critical path is the longest path through the network diagram, right? It determines the shortest possible project duration, and activities on the critical path have zero float. So float, it's more like a slack or not having any wiggle room. Okay, so the first one is total float. So we need to understand these acronyms, right? LS is late start. ES is the early start, LF is the late finish, and EF is the early finish. So it's just the difference between, as you see here, late start and early start, okay? Or the late finish and early finish. The difference between those two will give us the float. It's called either just float or total float, right? And so other way to interpret is that how long an activity can slip without delaying the project end date. Okay, that's what total float is about, without delaying the project end date. And the critical path activities have zero float. Okay, the other one is the free float, which is the early start of the next minus early finish of the current one. So free float tells you how long an activity can slip without delaying the next activity. So free float is among activities, while the total float is for the overall schedule. And so this is useful when coordinating handoffs between teams and so on. All right, and after that, the next one is the PERT estimation, which is also called the 3-point estimating. PERT stands for Program Evaluation and Review Technique. And so its formula is the expected duration equals optimistic timeline plus 4 times most likely what it can happen, and plus pessimistic, and that all divided by 6, because there are total 6 times we are kind of doing that addition. Okay, so that's the formula for the PERT or 3-point estimating. And the answer that we get, it's kind of weighted average that leans towards the most likely estimate. And it's useful when uncertainty is really high. Okay, and the last one is standard deviation, which is basically the pessimistic minus optimistic divided by 6. This one is about quality management. That is about understanding the cost of doing things right versus the cost of doing things wrong. Okay, so this formula help project managers to justify investment in prevention and understand variation in processes. So the formula that you see on the screen, cost of quality, that equals to prevention plus appraisal plus internal failure plus external failure. Okay, so it's kind of total cost of ensuring quality plus the cost of failing to meet quality standards. Okay, so it's not just about defects, but it's about the entire quality system of prevention, detection, and correction. Okay, so I'm not going in detail about the breakdown here, but basically you need to understand that prevention cost is the upfront investment to avoid defects. Appraisal cost is the activities that measure, evaluate, or audit quality. Internal failure cost, it's like defects found before the product reaches the customers. and the external failure is defects found after the product reaches the customer. Okay, to keep it on point here, so the main interpretation that we need to know is that do you understand that prevention is cheaper than failure, right? And the next one is sigma calculations. So a sigma tells us how much variation exists in a process. Okay, so quality control is about understanding whether variation is normal or a sign of a problem. So standard deviation and control limits are for quality control. All right. I think we are not going too much in detail here. So if any other questions, we can discuss, or we can move on to the next slide, which is about the procurement and control management, contract management. Okay, so that is about understanding who carries the risk, the buyer or seller. So here you see the first one is the point of total assumption, PTA. Okay, that is more of ceiling price, which is the maximum the buyer will ever pay minus the targeted price. Okay, and then that is divided by buyer's share ratio plus target cost. Okay, don't worry too much about this because it's rarely tested in the real exam. I didn't have any question on this one.
Yes. Thank you. So project performance with EVM introduction. So what exactly EVM is? EVM, it's the Earned Value Management. Earned Value Management is a core project management tool, which is primarily used to assess schedule and cost performance throughout this life cycle of a project. So on the PMP exam, EVM questions typically fall under process domains within the cost management knowledge area and monitoring and controlling process groups. Now, however, EVM concepts may also appear in cross-domain scenarios, such as like procurement or schedule management, especially in hybrid or predictive project environments. At its core, EVM provides a systematic method to measure project performance, manage and mitigate the risk, improve communications among stakeholders, and accommodate changes in project scope effectively. Now, this technique answers three fundamental questions. One is about the past performance, which is where have we been? Something on the current status, like where are we now? And forecasting future performances, which is where are we going? So traditionally, EVM has been predominantly used in waterfall projects due to their defined scope and linear progress tracking. However, with the increasing adoption of hybrid project management approaches, there are growing examples and methodology for integrating this EVM concept into agile framework. Understanding EVM and its application in different project environment is essential for both project success and PMP exam preparations. Now let's look into the EVM terms and categories, which is there are three key data sources. One is the PV, which is planned value of the work schedule, actual cost, which is AC, the actual cost of the work to be completed, right? Earned value, EV, is the value of physical work actually being completed, and important variance and performance index formulas, etc. Now, when we look into the formulas, the CV, which is the cost variance, is the difference between earned value, EV, minus actual cost, which is AC. So SV, which is schedule variance here, this is the difference between earned value and planned value. And if we look into the SPI or CPI, so CPI is earned value by actual cost, which is cost efficiency. So this is like cost performance index, cost efficiency ratio. And SPI is the schedule performance index, which is schedule efficiency ratio, which is EV by PV. Now, complex forecasting formulas example, these are like EAC, which is estimate at completion, ETC, estimate to complete, VAC, which is variance at completion, to complete performance indexes, TCPI. All of these are really important to understand and to learn these formulas and terms. PV, as I mentioned, it is planned value. This is how much work was scheduled to be completed by a certain point, expressed as a percentage of total budget at completion, which is BAC. Earned value, EV, it represents the actual value of the work completed so far, measured against BAC. BAC is the budget at completion. It shows progress in monetary terms, not just time or task completed. Now, actual cost is the actual money spent on the work performed so far. The difference and ratios between these values gives us insight into project performances like cost variance, schedule variance, cost performance index, CPI. If CPI is greater than 1, this means that there is cost efficiency. Less than 1 means cost overrun. Schedule performance index, which is SPI, and SPI greater than 1 means ahead of schedule. Less than 1 means delay in schedule. So advanced forecasting of these formulas like EAC, ETC, VAC, TCPI, this helps predict future project performance and guide management decisions on adjustments needed to complete the project successfully. And understanding these terms and calculations is essential for effective project management and control, and is a key focus area for PMP exam questions. So learn these formulas. It might be specifically on variances and understanding how these EVM overview is, what is greater than 1 or CPI greater than 1 or less than 1. What exactly does this mean? These are really very important to know. I'm moving on to the next slide for EVM interpretations. Palak, you want to take this?
Yes. As Arshna explained, the EVM interpretations are really key. So you need to know at what level it's on track or off track, and what signs that we need to look for, greater than, less than, or positive, negative signs, and so on. So when the difference or variance for cost variance or schedule variance are positive, okay, then it's good news, okay, that you are on the better side of your project. But if it's negative, then it's off track here. If cost variance or schedule variance are negative, then it's off track. And so more of the other way you can say that when it's positive, it's ahead of schedule or under budget. Okay, and when it's equals to 1, the ratio, the cost index performance is CPI, cost performance index, here's the typo, and schedule performance index, SPI. If they are equal to 1, then it's on track. But if it is a ratio is greater than 1, then it's ahead of schedule or under budget. Okay, so the cost is either over or under, and schedule is ahead or behind. Okay, so you need to have that clear in your mind. Okay, and also this to complete performance index, it's more of the estimation. If that is greater than or equal to 1, then it's also on track. All right, and if the ratio cost performance index is less than 1, then that means it is over budget. And if schedule performance index is less than 1, that means it's behind schedule or it's delayed. Okay, and if to complete performance index is greater than 1, then it's also off track, is the how much work is still remaining. Okay, that's to be completed performance index. All right, and there is a way to do correction here in our project status, right? So there are different terms like fast tracking, labeling, crashing, and smoothing that you will also need to understand. But the other way to evaluate is you need to know the number and how much percentage it reflects. So for example, here 0.9, so it's actually 0.1 less, right? So if you convert it to percentage, it will be 10% under or behind. If it's 1.1, then it's 0.1 greater, right? Then it's 10% over or ahead. So that's a really key interpretation. All right. So it's very important to know the graphic performance analysis. So here you see X versus Y. So on the X-axis is the time, and on Y-axis is the progress. Okay, and there are three curves here. The first orange dotted line is the EV earned value. Okay, and then the green one in the middle is the planned value, and the red one is AC, actual cost. Okay, it's not always fixed. This is just an example. Okay, they can move around. It could be one above other or things like that. So we need to understand the difference, which one is higher. Okay, and whether that variance will be positive or negative. Just by looking at the graph, we can figure that out. So here we can see EV versus PV. Okay, so PV is higher in this case. That means that planned value is higher than what is actually earned. Okay, so in this case, it will be negative. So if we do EV minus PV, since PV is higher, it will be a negative value. So the schedule variance is negative, means is behind the schedule. Okay, and now if we do AC versus EV, AC is also higher in this case. So actual cost that's spent for the project is more than what is actually done, what is earned for the project. So EV minus AC will be also negative. So if you see that purple bracket, that is the cost variance. Okay, so since it's negative, that means it's over budget. All right, and the thing you need to be clear that AC and PV both are compared against the EV. Okay, so if you know those basic formulas, you will be able to interpret this well. Okay, next is just basic EVM overview. And it's very simple. So budget terms, you know that cost variance and cost performance index are for budget. Schedule variance and schedule performance index are the schedule terms, and the remainings are more of estimates. Okay, but more common are these variances and indexes. Okay, all right. Hope that helps. Moving on to the next slide.
Next one is a summary and study tips. Something which we keep saying, don't overstudy maths, right? Create a formula sheet, review it daily. Consistent repetition builds the confidence and recalls, right? So practice with scenario-based questions, applying formulas in context deepens understanding beyond the memorizations, etc. So use time box drills. So simulate your exam pressure by solving problems within strict time limits to improve your speed and accuracy for sure. Practice. So it's always practice, and blend conceptual understanding with maths. So knowing why a formula matters is as crucial as knowing how to solve it. So this makes your problem solving like adaptable while you understand the question as well, right? So know which math really matters. Again, don't overstudy. In today's PMP, maths questions are like few. It could be 5 to 10% hardly. Conceptual, and they are light calculations. They are often embedded in scenario. So it could be scenario based as well. So focus on EVMs, earned value, critical path basics, your PERT, which is very light, simple forecasting, and like burn rate, velocities, agile, try to understand those concepts as well. You can skip complex network diagrams, deep statistics, long formula derivations, right? Master EVM using logic. don't memorize, not memorization. So use the logic, master these EVM logics. Instead of memorizing, lead with patterns and the core values, etc., like PV, planned value, EV, actual cost, the formula of the index, CPI. Even CPI is less than 1, it is over budget. SPI is less than 1, which is behind schedule. So the one of the exam trick here, if they say project is behind schedule and over budget, this had come for me, at least I saw this kind of test questions. The correct answer, whenever the project is behind schedule and over budget, it means SPI is less than 1 and CPI is also less than 1. So even before calculating, you can eliminate wrong answers here, right? ESE questions, most PMP mistakes happens here. Identify the scenario first. Past cost issue continues. EAC is equal to BAC by CPI, or future work at planned rate. EAC is actual cost AC plus BAC minus EV, or cost schedule, both impacts, right? EAC is BAC by CPI into SPI. So the tip here is, if the questions are current performance is expected to continue, what it means use BAC by CPI. Or one-time issue, if it is one-time issues, that kind of logic, so use AC plus BAC minus EV. Now, critical path, all about critical path is think what delays the project. You don't need full diagrams often. You try to understand the questions, what it means. Longest path is equal to the critical path here. Zero float is equal to critical. Delay on CP is project delays. Delay on non-CP means may not impact the end date. So the exam framing is like, which task should the PM focus on, right? So answer here would be task on the critical path. Task on the critical path should be the focus. So task with float should not be the answer. Now, PERT estimation, what Palak mentioned in few slides back, that's formula. Just remember that formula. PERT is but PMP often tests like range thinking on PERT as well. So optimistic is the best case, pessimistic is the worst case, most likely dominates. If options are close, pick one closest to maybe M most likely. Don't go for extreme answer. Yeah. And agile maths, it is mostly common sense. You may see velocity, story points, or burn down interpretations. The logic on these example could be like velocity, what's the average point per sprint? Slow velocity means more sprints needed. Flat burn down means blocker exists. So there is no formula here. It's all about interpreting and interpret the trends in the questions. Before calculating, you should ask, should the number be higher or lower than BSc? Over budget, ESC greater than BSc? So there could be some tricks of even not even calculating and just looking into the scenarios. Yeah. So save time where you can. Do not spend more time on simple questions. Anything which is greater than 90 seconds on math question could be something that you need to think of. So practice. If calculation looks long to you, eliminate two options, pick the best remaining and move on. So PMP is not testing the calculator skills here, right? It's testing the decision logic, simple maths formula, wherever it is, and understanding the concept as well. So practice the right way. That's very important. Don't practice maths in isolations. Instead, you take full length PMP questions or focus on why this formula, what's the logic behind this formula. The recommendation could be your study hall as well. That's something which we have also heard from many people that it definitely helps. Mock exams as much as you can take and understand those explanations on the mock exam. So if you're confused, yeah, in any question, just ask, what would a good project manager conclude here? It could be because of confusion may occur because two of the answer could be similar. So avoid extreme, reflect your realism, and focus on the trend and impact.
So feel free to connect with us.
Yeah, again, thank you so much. Thanks.